Hello friends, in today's question, two blocks A and B are connected to each other by a string and a spring. The spring passes over a frictionless pulley as shown in figure. Block B slides over horizontal top surface of a stationary block C, and block A slide along the vertical side of C, both with the same uniform speed. The coefficient of friction between the surfaces of the block A is 0.2. Force constant of the spring is 1960 Newton per meter. If the mass of block A is 2 kg, calculate the mass of B and the energy stored in the spring. So there are three blocks A, B and C. A is connected with B with the help of this spring, which is connected to block B using this string. Let us draw all the relevant forces which will be acting on these blocks. So this is block B. Downward direction we are going to have MBG, and as it will try to move towards right side, so we are going to have a frictional force, let us call it as FRB. It is connected with a spring to the block A, and there is a normal here, let us call that NB, and for A we are going to have MAG, and it is going to have a normal NA, and we can say T will be tension here and tension here, and in this direction there will also T, and in this direction there will also T. So as block A will try to move downward, we can have a frictional force FRA which will be acting in upward direction. So these are the respective forces. First of all, as spring and string are connected with block A and B, and A and B, and this is block C, A and B both are moving with constant velocity. So you can say mass block A and B are moving with constant velocity, therefore we can say that forces will be in balance as there is no accelerated motion. Next, the string and the spring are in continuity. Okay, we can say string and spring are in continuity. So we can say tension in the string, let us call that this string, will be equal to tension in the spring, and which we are going to say will be equal to T. So let us consider for block B, you can say for block B, so as it is moving with constant velocity, tension will be equal to FRB. Sorry, for block B, in horizontal direction, tension T will be equal to FRB, and we can find out FRB will be equal to mu into NB, which is equal to mu into MBG. So we can write our tension T is equal to mu MBG. Let us call this equation number 1. Similarly, we can do it for block A. You can say for block A, in vertical equilibrium, T will be equal to MEG. And T is equal to, we have upward force also FRA, so let me write it FRA, and from we can find out value of FRA. FRA will be equal to mu into NA, which we are going to get as NA will be equal to MEG cos of 90. So from here we can say FRA will be equal to 0. Therefore, we can summarize this equation: T is equal to MEG. Let us call this equation 2. Equating equation first and second, from equation 1 and 2, we get mu MBG is equal to MAG. Here G and G cancel out, so we can say our MB is equal to MA divided by mu. We substitute the values, we get MB, MA is given as 2 kg, friction is given as 0.2 coefficient. From here we can say MB is equal to 10 kg. So this is the mass of block B. This is mass of block B. The second part, we are supposed to find out energy stored in spring. So we can write, for the spring, tension T will be equal to K multiplied by Y, where Y is the extension. Where Y is extension in the spring. So from here we can find out a value of Y. We already know tension T is equal to MAG, so we can say KY is equal to MAG. Therefore Y is equal to MAG divided by K. Mass is 2 9.8, and coefficient is given as 1960. You can see that our y is given as 10⁻⁻² meters. And finally, the energy stored in the spring. Energy stored in the spring is U, and that will equal to half ky square. We substitute the values. U is equal to half, k is 1960, 10⁻⁻² whole square, and we get U is equal to 0.0985 joules. So this is the energy stored in the spring. This is energy stored in the spring. So this completes the question. Thank you.